Hello, colleagues. Welcome to another session of the linear programming series, where today we are looking at the least cost method in transportation problems. Okay, what's about transportation problems? Transportation problems are to do with finding a way of minimizing the total cost of shipping or transportation from the warehouses to the destinations. Okay, we want to minimize at its barest this cost of transportation or shipping. Okay, so you have this. Okay, let me do this. You have this, that, and that, O1, O2, and O3 as your sources or your factories. Basically, the capacities of these factories are 300, 400, and 500. And you have destinations or stores that particularly need these products. Okay, and you have D1, D2, D3, and D4 as your stores or your destinations where these particular products are supposed to go. And these stores require these capacities here. Okay, having said that, how do we use the least cost method to arrive at the barest minimum cost? Okay, we first begin to identify the cell with the minimum unit cost. Okay, these are costs. These are unit costs that we have in these boxes. These are unit costs. So we have this, that. These are unit costs. So we identify the minimum unit cost. In this case, the smallest value we have in these cells that we have is 1. So basically, we begin to allocate in the boxes that have the minimum unit cost. Okay. So in this case, this particular box is identified by this particular column, and this row. Okay, and if we are to define that particular cell, we are saying that cell is O1, D2, isn't it? Okay, so meaning what our objective here is, is to look at our O1, the supply that O1 can give us, and the demand that D2 can needs. Okay, and when we identify these two, when we circle these two, or when we put them into consideration, you get the lower of the two, the smaller of the two. In this case, the supply, this guy O1 can only supply 300, but this guy needs 350. So we give everything that this guy can supply, so it's 300, isn't it? Now when we do that, if we supply everything to D2, meaning O1 will not have anything, isn't it? He'll remain with a 0. Okay. And if we supply 300 to D2 will remain with a 50, isn't it? Okay. So we identify the next cell. Which other cell contains the second smallest, since we have already allocated into the smallest, and this particular supplier O1 doesn't have anything, meaning they can no longer supply. We put a line to cancel everything that this guy has, meaning he can no longer supply to D1 or destination 3 or destination 4 because he now has a 0. Okay, so which one is a smaller now? So we have 2 and 2 there. And now this is a dilemma. You realize that you have 2 digits that are that are the smallest at this particular point in time. How do you prioritize? Okay, you know that rows are going in this direction and columns are going in this direction. So if at all they are in different rows, start counting row 1, row 2, and row 3. So priority starts with starting from row 1. So if the smallest is in the first one is in the row 1, you start with the row 1. If the other one will be in row 2, then that will be the case. If you are looking at columns, if you have them in different columns but in the same row, you column 1, column 2, column 3, and column 4. Prioritize from the smallest column, from the first column. Okay, priority starts from this direction going that side. Okay, in this case, priority starts from top going bottom. In this case, we have a 2 here and a 2 here. So we have column row 1, row 2, and row 3. So row 2 comes before row 3. So we prioritize this particular box. Okay, so what are we having there? We have 400 in the supply and 250 in the demand. So we give 250. When we give 250, we have a 0 on the demand. We no longer need anything. We have fulfilled our demand. Then we'll have a 150 on the other side, isn't it? Okay, so since we have these two, now we have the remaining two. We can now go to that particular two. Okay, since we are going to that two, what are we having? We have a 500 and a 200 there. So we allocate 200, everything that you need on D4. Okay, meaning here you remain with a 300, and here you would have depleted, you have 0, right? Okay, 3 comes next. Now 3, and maybe let's start with cancelling out what we have depleted. We have depleted this. What else have we depleted? We have depleted this. Okay, we have 2 3s here and there. What do we do? Okay, let us look at our rows. Row 1, row 2, row 3. You realize that the 3s are in the same row. Okay, so meaning we cannot use the row to determine which one we are going to start first with. So let's count the columns. We have column 1, column 2, column 3. Okay, you realize that this particular 3 comes first. This column comes first before this one. So we prioritize this particular column. Okay, what are we having? We have a 50 remaining there since we gave out 300. We have a 50 remaining and we have a 300 remaining this side. So we give the 50 that this particular guy needs. So we'll remain with 0 there. But here we'll have 250, isn't it? When we remove 50 there. Okay. Then we can go to the other 3 remaining. So we'll cancel out everything here. Okay, so when we are allocating this, in these 3, we have 400 and 250. So we give 250 where it's due, so that we allocate everything that all 3 can supply, meaning we'll have a 0. If we allocate 250 there in this particular demand, we will remain with 150, isn't it? Okay, what sale out? So meaning this guy is also out of consideration. We remain with only one box here, which is this one. Okay, in this box we have a 150 and a 150. So basically we allocate. At this particular point in time, you will realize that we have given out everything we have 0 there, we have 0 there, we have 0 there. Even here, 0, 0, 0, excuse me, right? Okay, meaning we have done 80% of the question. Now let us calculate the total cost. Let's clean up this table and calculate the total cost. Okay, having cleaned up the table, what we are saying is that total minimum cost is equal to the summation of product. So these are the products that we were allocating, multiplied by the unit cost. Okay, let's see what we are going to have then. Okay, so you realize that we get the 300 multiplied by 1, this 250 multiplied by 2, this 200 multiplied by 2, and we are getting this particular line of digits. And if we can add these ones, we realize that we're going to get a 2,850. Okay, and you have gotten your minimum total, or your total minimum cost for transporting every element or every commodity from these particular supplies to these demands or destinations. All right, see you in the next class.